Hello and welcome to the Data Engineering Podcast, the show about modern data management. Atlan is the metadata hub for your data ecosystem. Instead of locking your metadata into a new silo, unleash its transformative potential with Atlan's active metadata capabilities. Push information about data freshness and quality to your business intelligence, automatically scale up and down your warehouse based on usage patterns, and let the bots answer those questions in Slack so that the humans can focus on delivering real value. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, to learn more about how Atlan's active metadata platform is helping pioneering data teams like Postman, Plaid, WeWork, and Unilever achieve extraordinary things with metadata. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Nick King about the utility of behavioral data for your data products and the technical and strategic considerations to collect and integrate it, and some of the work that he's doing at Snowplow to support all of those efforts. So, Nick, can you start by introducing yourself?
Sure thing, Tobias. It's great to be here. My name is Nick King. I look after product marketing and the US business here at Snowplow.
And do you remember how you first got started working in data?
I've been in data for a really long time. So probably the first time was migrating off of AS400s and mainframes, off of variants of DB2 into various other data warehouses a very long time ago. So it's been a long time. Got to work on the early days of what became SQL Azure. I worked on the early days of what became BigQuery and Joomla and some of those pieces. Worked on a bunch of AI projects in my previous life at a company called Data Robot, and then ended up at Snowplow really because I kept trying to solve problems and I kept pulling up Snowplow to solve them. And so kind of the history was I was back in New Zealand looking after my parents, sort of post-COVID, just the end of COVID there. And I had 2 weeks locked in a quarantine facility in New Zealand, which sounds nice, New Zealand, but it's an army-guarded quarantine facility. And I was constantly pulling up these projects I wanted to work on. Just in frustration of dealing with bad data, I kept creating my own data. And I knew the Snowplow guys, I was joking, I was like, hey, every time I try to solve a problem, I keep pulling you guys up. And that sort of started the conversation, why don't we start working together to solve it? So that's a very TLDR of sort of how long I've been in data and really sort of how I ended up where I am today.
The mention of AS400s brings back memories as well, because one of my first jobs in tech, I was a sysadmin, and one of the systems that we had as part of our environment was an AS400. And one of the projects that never actually finished before I had moved on to another job was actually bringing in a brand new AS400 and running the migration to that. So
they're really great systems, actually. I met someone the other day that still maintains them, and you could set and forget them, and they work pretty resiliently. It's been a while since I've cracked open RPG code, though, so I hear it's a lot easier to work with.
Yeah, I never actually had to work in the code layer. I was more just dealing with the network interconnects and making sure that I was able to talk to the right things.
Yeah, that's a true. I remember putting SNA over IP, so that's a whole different podcast probably. Yep. But I think those fundamentals and those types of data architectures have really helped over the last sort of 20 years with them because, back then, we really were hardware engineers trying to get performance out of that stuff. And to be fair, a lot of that stuff's gone away now. But what we learned in that space makes us much better at how we architect data warehouses and how we put data together today. So I'm glad I had that tour of duty.
Absolutely. That brings up the kind of key phrase that I have said on this podcast many times before, but the idea of mechanical sympathy, of understanding what the hardware is actually doing at the fundamental layer and why you don't want to write your code that way because it will just abuse that hardware and you will be wasting cycles.
100%. I would say even 10, 15 years ago, a large part of high-performant data management was understanding the drive, the read-write throughput of those data systems, and then how you'd also sequence the networking. And a lot of projects solve that, right? I worked on a technology, it was called Spanner, and we're using it in Google Maps engine. And what it would do would actually time slew the packet to write the data in their same sequence, so you didn't have to have a locking mechanism. So each hard drive had a GPS chip, and then understanding the time slew of how long that took to get to a hard drive in Germany, which is a hard drive in Virginia, was allowed you to sort of concurrently write all that data globally. And so, there's so many of these interesting projects that often the underlying mechanical elements have a huge impact on how they perform. And even columnar data warehouses, again, similar types of scenarios.
Absolutely. In terms of the topic at hand, you mentioned in your introduction to how you got involved with data, some of the idea of data creation, of having to create data to be able to solve a particular problem. And that also fits in with the idea of behavioral data. And I'm wondering, before we get too far into it, if you can just give your working definition of what constitutes behavioral data and data creation and how that might be differentiated from some of the other types of data sources that people are likely working with.
Yeah, so let's start with data creation. So I think, for the last 30 years, really since like the Matica started doing ETL pipeline transformations, we've all been in this sort of ETL concept, right? Where you take data from somewhere, you transform it, you load it, schema first, schema second, doesn't really matter. There's always this concept that you had to source the data and do something with it. But as we look at the category of data creation, there's something very different in the way that, modern data required how that data was being created. So not just the lineage of the data, like where it was being created, but also how it was being created. And what I learned particularly is building a number of ML models in my previous life, but also just trying to maintain enterprise accountability with data is that it becomes almost impossible to have a common understanding across a whole organization of your data. So I might understand parts of the data, you might understand parts of the data, and everyone's trying to apply their lens, their ontology to that data. And what I found is that most people were dissatisfied with the data anyway, right? You're kind of grabbing Salesforce data to describe one thing, or Google data to describe something else. And that sort of concept of passing that ownership to someone else sort of didn't make sense when you're trying to make really important business decisions. And I think what's held most people back from creating their own data is the complexity or the accessibility to create that data. And if you look at the way things are architected today, most of us have access to drop, an SDK onto our website or drop JavaScript onto our website. We have the ability to emit events from Salesforce. We have all these different types of business systems, whether it be IoT devices. They're all really capable of emitting some form of event. And so really when we talk about data creation, it's really about pushing out to each of these different endpoints, these places where something happens when an event occurs, the ability to create that event and then run that through a pipeline where you really have this concept of schema always. And so we talk about schema first or schema second. When you live in a data creation concept, you're creating data, but then your schema is always evolving as that data gets created. And the way that you evolve schema is you have good events and bad events. Good events obviously map schema, bad events do not. And this also has a whole bunch of interesting things that happen. One is you can evolve the schema. Bad event could mean something upstream changed. Okay, that's schema evolution. Bad event could be something doing something bad. Could be something attacking that event. Okay, that could also be something interesting. And traditionally, where you have an ETL pipeline, you really have no visibility upstream. So if someone changes something, your whole pipeline breaks, or you just don't know, and your data drifts. And that's bad. And so all these problems existed from just the sort of lineage, the sort of waterfall approach that ETL had. And so that's got us started talking much more about data creation. And it turns out when you kind of look at how you think about the type of feature tables or metric tables you're trying to build, if you have a common understanding of your data and the ability to create it at scale and do that schema evolution, it's far more performant than trying to maintain 50, 100 pipelines of data and always maintain those ETL pipelines. So that's, the definition of data creation is being able to create data across all of your enterprise systems, do so in an event-based way, and having that sort of schema logic behind it. So that's the first part. That's sort of what Snowplow does. It's the core of what Snowplow is. But then as you've got control of the data creation, it opens up a second level of interesting things you can start doing with it. If you have this evolving schema that you understand, if you know the lineage of the data, then you can start to link those events together in a way that's also predictable. You can recognize ways of stitching those events together, and you can start to have much more control of what that data landscape looks like. So I'll give you a practical example. We work with a company called Warby Parker. They sell glasses. You go to their website, you check some stuff. You go to their augmented reality app, you put the glasses on your face, you go into their store, you kind of swipe your credit card, you do what have you. That's three different, very distinct journeys in a retail experience. And in those three distinct examples, traditionally you have multiple tools, ETL, you try join it, and you might figure out you pulled that off 6 months down the line or 3 months, or maybe if you're really good, 2 days after it. But it's very hard to take a real-time action on that data. What we do for them is we actually stitch it together, near real time. So as the event comes through, as we know it, we can start to inform the AR app or the in-store promotion or the website to actually change the behavior in real time. So because you understand you're creating the data, you're seeing the event stream come through, and you can stitch it that way, you've got far more powerful types of behavioral concepts you can also start to put together. So that's one example of a behavioral data concept. But to get into the data structure of that, think of the data being layered this way. You have effectively the system data, what created that data. You have the transaction, what I moved from one place to the other, what was the payload of that data. You have the demographics, who was that? And then behavioral data is linking each of those events together. Say, hey, Nick came to my store, he went to this place, he did that, he then bought, he then had a refund. And that's kind of the holy grail, I think, for a lot of us. We think of a data pattern, but we very rarely can stitch together those time sequence events to do that. And so behavioral data is taking all those dimensions and putting them in a logical, connected way to kind of drive extrapolation from it. And that makes ML far easier. But even just, simple, what was the typical journey and how often that journey exists can be much easier to kind of replicate as well. So that's two very big examples, but I think it kind of covers both data creation and behavioral data for you.
Yeah, I like the framing of it too, because the way you're describing it, behavioral data is a subset of that data creation problem. And the way that you're describing it, it also comes off as being distinct from the event tracking approach that a lot of people might be familiar with, particularly with things like Google Analytics or Segment, where you have an event and it is a discrete event and doesn't necessarily have contextual or semantic linkage with any other event, where even if somebody is on a website, maybe the semantic or contextual linkage is that it's within a given session on that website, but you don't necessarily know anything else beyond that unless you have already done the work to kind of add that extra context. I'm curious if you can talk to that distinction between event tracking, as a lot of people understand it, and how it maps into this, I guess, superset of the problem space of behavioral data and some of the extra pieces of information or some of the additional mechanisms or utilities that are necessary to be able to kind of level up into that behavioral data approach.
There's two common ways I see this done. The first obvious one is creating one view of it ID. So let's just say your email address and all the different events that exist with that, and then how those events are linked together. So you end up with this, what I call a behavioral profile of an entity. And the behavioral profile could be you, it could be Tobias's house or Tobias's company. So we have relationships between, buyer groups or purchasing groups. That's sort of like a human example, but the same exists for systems. There's always these relationships that exist. And so you want to create one view of all the events with the linkage of events to provide that. What is the view of Tobias right now? That is incredibly powerful and informative for all sorts of systems, sales performance, market research, market targeting, and having that in one place can have a really big impact on how you think about that behavioral data. And that today is how most people think about what is behavioral data. But there's another set of behavioral data, which is also really interesting. When you start to do that linkage, when you take an event and you say, okay, this event was precursed to this other event here, and this was the time between those two events, and then this event was linked to this event, and this was the time between these events, you end up with this fourth dimension effectively. So you have what is the event at what time, and then how do these get linked together? And so you end up building this time series journey of what's happening. This is really important because you start shifting to almost a graph approach. So you basically have joins of events. But what's really interesting here is it's really hard for machine learning to actually predict and join those events together without some logical connection. So if you were trying to look at your mouse clicks and say, okay, this user clicked these 3 places and converted, or this person clicked these 4 places and converted, the ML will generally try find the laziest way to solve that problem. So it's always going to look at what converted. So you end up with lots of the primary conversion becomes people go from docs or getting started. You end up doing all this weird stuff to try and make the ML data usable. But when you have the graph join and explain the join between the data, then suddenly the ML sees that as a workable feature and it stops trying to cheat. Then you also don't introduce your own biases to trying to fake a journey. So that's why that actual joining of events becomes a really powerful way of sequencing a journey, and particularly for time series modeling, or even simply just choosing a repeatable journey, these are the 4 steps I want to understand. Is there a way to make it 3 steps? That linkage becomes immensely powerful. And so as you're doing data exploration, being able to say, okay, show me all the customers that started with this end step and show me all the variations that got them to that end step. By being able to stitch all those together, you have a far more informative data set. And so we start to see that used a lot more for web optimization, product optimization. And we're starting to see it used somewhat for dynamic sort of optimization of some things. Like we have one customer, Charlotte Tilbury, they use some of that data to optimize sort of their cart performance. And I'm using web examples because they're the easiest ones to sort of explain. But, that type of optimization is really interesting. Another example, a large financial organization uses a similar type of behavioral data to understand, is there a security risk? Was the way that this action occurred, did the behaviorally that event look like it was consistent with other activities that led to that event? But able to string those together, you have a much broader profile of what led to that event to happen. So without speaking so meta, I'll use another example. Bad actors tend to have different behaviors, right? So one might be if you've got like a script trying to hack a website, the mouse might not move. And so you don't really look at did the mouse move before this event because they'd be tracked as different events. In behavioral data, the mouse moving event would be part of the same journey as something else. And so did it move in a organic way or inorganic way? So did it go like plus X1, plus, or did it move in a way that looked like the person had muscles? And so just looking at the organic versus non-organic movement is kind of interesting. Another one is looking at like, okay, was there metadata around the payload, which was interesting. So were there multiple email addresses? So it turns out bad people tend to have lots of email addresses from people that aren't there. And they might have 400 variations of like at Gmail, at Hotmail sitting in the cache. Most good people, like we might have 4 or 5 email addresses. That might be extreme. We're not going to see thousands. And so those types of behavioral elements mixed with like at this stage, what did we see and how did that come through? Were there organic movements? That sort of sets up how behavioral data can be used. So I gave you an e-commerce example, a security example, an email example. All of those are why behavioral data is so interesting. But the hard part is if you don't create it deliberately, it's really hard to sort of emulate it or kind of instigate it.
And that brings up the topic of things like tracking plans that I've heard people discussing where they say, okay, this is the event that we want to track. This is how we're going to construct it. This is where we're going to record it. And I'm wondering if you can talk to some of the organizational patterns that are most effective and most useful for being able to work with this behavioral data and some of the ways that that maps into the actual technical application and technical, I guess, like task flow of how the application and data teams work together to be able to understand what are the pieces of information that we want to track and how.
Yeah, I mean, I think I see this a lot where there's like a Google sheet that exists in the business and that's like all the tracking plans and like, there's usually like Jira ticket numbers and is it up to date? And there's one poor soul that kind of tries to maintain that. That's one way to do it. Like at least it's in one place. But I see that a lot. I think what we see works well and what we sort of strive for at Snowplow is we have this concept of a tracking catalog. So we go through and we actually enumerate all the schemas and we give you the idea of what are you tracking, what are the events, what are the entities, what's the version number of that. And so we try and put over the top of the schema an element of what's being tracked and where that's at. And so you always want to be able to go through and quickly enumerate and maintain a catalog of your schema, but also understand the relationship of your tracking catalog and your tracking plan. And what I think is a best practice, what I believe is a best practice there is being very deliberate upfront as to your events and entities and being, methodical about the version numbers of what you're trying to do. Like have a deliberate rollout process. And why the Google Sheet way and other ways doesn't work as well is because you sort of work async, but there's not really a very consistent release cadence for that. And so it's very easy to like each individual is delivering the exact tracking they need to solve that problem. And you get these weird things like duplication of events and other things. And so you end up with like that duplication. When you have a tracking catalog, it allows you to think of all the events that might come, whether they be system events, DevOps events, user events, behavioral data, what have you. That overall universal view is really the best practice that we put into our product that we encourage folks to do. You could do it in a spreadsheet, it's harder, but that view of having that release management almost approach your tracking catalog and your tracking plan is key. And then the other piece that we kind of innovated around this is, often you sort of take that tracking plan and it just becomes you just add a new column to some table somewhere and is it, right? And so you end up with this table sprawl. And so that's great because you've got your table, but someone at the end has to rejoin those back into something else. And so the sort of never-ending Ponzi scheme of ETL processes keeps getting recreated. And so the way we would look at it is we'd say, allow your schema to evolve. And so if you need to add stuff, it sits in that schema, the tracking catalog and the tracking plan's updated. And then it goes into like force yourself to have one universal table to kind of bring all events together. So an example of someone who does this really well is Strava. I don't know if you've seen the app. It's like a fitness app, kind of measures all the segments. And so everything in Strava is instrumented in Snowplow. And everything from the way their infrastructure systems work, for the way their application works, the way everything kind of works is effectively an event, a tracking catalog, and it goes in this overall flow. And they build one master atomic table. And that atomic table then gets aggregated or modeled to what other organizations need. Having a tracking plan and catalog that maps back to this concept of an atomic table that then gets modeled to the data products people need to use provides a lot of consistency, but also it solves one universal problem, is that everyone queries from the same source. So you have this pure lineage effect where it's like, we know it was created because we had our tracking plan and catalog. We know it's in the atomic table, so we know these are all events, and then we aggregate from there, and everyone is sourcing from that atomic table. And that reduces table sprawl, but it also stops like drift and forking of all these different tables. And then, in some ways, I think we're all working towards this concept of like a blue check mark for data. And I'd love to one day see a table with a blue check mark on that you have like the creation, the pipeline, the tracking plan, and then it's like, okay, guaranteed, everything is guaranteed to this table. And that's why the tracking catalog, tracking planning concept is one that's getting so much attention right now. Just make it much more usable, because the Google Sheet View, it just, it sort of works, but not quite well enough.
Absolutely. And another dimension of this behavioral data conversation is that a lot of the ways that people at least initially interact with this concept is through something like a JavaScript tracker on their website. But when you talk about it, it's a lot more detailed than that. It's not just the events that happen to get fired from the website. It's also the events that are triggered by, the backend system that sends an email or the application. And that brings up the broader concept of how we as data engineers typically interact with building these data flows, where largely we rip the data out of the database, pull it out of context, try to reconstitute it, sort of becomes the MRE of information. So I'm wondering, what are some of the ways that this principle of data creation can serve to reduce the burden and improve the signal to noise ratio for these data integration efforts, where rather than just pulling all of the raw records out of the database and hoping for the best, you're actually collaborating with the application team to be able to say, give me meaningful events or give me meaningful records that I don't have to work on reconstituting, that can have a stable API, even if you want to modify the underlying schema, and then you just hand that off to me. I know what to do with it from here.
Yeah, I love that. And you touched on a couple great concepts in that. The first one is, how do you reduce the signal to noise and get that to a good and known state? When you do the extraction, you also extract the aggregations. And so often systems aren't designed to be event driven. They might be, a point in time system, so you lose that ability to manage change of state. The other thing is, like, one of the aggregations that causes a lot of problems for like ML and BI is it aggregated by second, by hour, by week, by organization? And you put that all into one table, and that number might be representing an entire day's activity, or it could be one specific event. And so that, when you're training on those types of those data sets, or even trying to, drive some level of metric table from it, it gets really complicated to try and fix that. And so what you do is you either reverse engineer it, so you divide it by 7 if it's a week and give a 1 day number. And so you end up with these weird normalization activities to try and make the data fit the aggregation the business is asking for. When you take an event-driven, data creation point of view, everything is effectively an atomic event, and then you can choose how you aggregate it. But then you can kind of go through and work through your different sources. So usually web's where we start, because it's pretty easy to deploy to, a tracker, a JS tracker. Then we tend to see mobile. Then we tend to see like sales data or like performance data. Then it's usually support data. And so each of those, you kind of go through this almost like a data contract discussion with the business. What is the data we expect? What's the data you need us to produce? And how do we make sure we deliver that data consistently? And then what is the right altitude or aggregation to provide that data? If you think about where a lot of like the churn comes for data engineering teams, it's like people, they might have said they wanted this aggregation, but they really meant something else, and they just didn't know how to articulate it. A system might be just doing weird things upstream. You don't have control of it. So you're always trying to like figure out why this thing's going rogue. And so the first big step forward for data engineering, when you take a data creation approach, it's almost like farm to table data. And so you know exactly where it started and where it ended up. And so you know what's happened. So you can have very specific discussions with the organization and get to very specific outcomes. You can document those or maintain them in schema, in versions. You end up with a much more robust alignment with the business. Number two is it gets much easier to define the data contracts and produce data products. And so, data contracts, we talk a lot about what is the data expecting. How do we make sure that the data is in line with the scheme of the business is expecting? And data products in some ways is, what do you produce and how do you provide that data back to the organization? And I think we are, for the most part, people I talk to, we're all kind of in this direction. It's like, we don't want to kind of give carte blanche access to all the data, but we do want to deliver curated data products that people can come and consume from. And we as data engineers, we want to be accountable for how that product gets created, right? We want to make sure we've got, organic data. We want to make sure it's, farm to table. I just came up with that, but this is kind of true. Like you kind of know exactly where it goes. That helps your consumers know it's good, but you also can stand behind it. You can also troubleshoot it. And so traditionally, you hoped it was right because your business constituents told you the data was right. Whereas when you do data creation, you can actually get much more authoritative and actually much more deliberate in what you're creating. So that's probably the first time saving I see. The second is just the cognitive load that it takes to deal with ETLing data. So I know Salesforce data relatively well. I think most of us do, except when people customize Salesforce data, right? And so you end up with all these different things, these different fields you're trying to work with. And so you end up with this like cognitive loading of trying to understand these data structures. And so the other thing when you take a data creation approach is the grammar, the way you describe each row, each column is defined in a way that can be repeatable. And what I find happen is that organizations are able to navigate that data much faster. So in the Strava example, you could be there and you kind of know what the data structure is going to look like. You know what the column names are going to be. They've got a really good governance approach. So shout out to those guys that are listening. It's world class. But the way they do the governance means that as a new starter, I'm able to get in there, use the data, and I know what to look for. There's not 3 columns called customer 1, customer 3, capital customer. There's 1 column called customer, and data management, data governance is also, you've got more flexibility, but much more control. And that cognitive load is really important as well. So those are the 2 things that I tend to call out. There's a bunch more too, but those are probably the 2 I'd start with as probably the 2 most important ones.
Prefect is the data flow automation platform for the modern data stack, empowering data practitioners to build, run, and monitor robust pipelines at scale. Guided by the principle that the orchestrator shouldn't get in your way, Prefect is the only tool of its kind to offer the flexibility to write workflows as code. Prefect specializes in gluing together the disparate pieces of a pipeline and integrating with modern distributed compute libraries to bring power where you need it, when you need it. Trusted by thousands of organizations and supported by over 20,000 community members, Prefect powers over 100 million business-critical tasks a month. For more information on Prefect, go to dataengineeringpodcast.com/prefect today. That's PREFECT. Another issue that is embedded in the concept of behavioral data is that of the ethical and privacy considerations that need to be balanced against the business objectives and the kind of analytical outcomes that you're aiming for. And I'm wondering how you have seen teams address that balance and identify what are some of those privacy and ethical considerations that they need to understand and how to include that in the process of determining what events to track, what specific pieces of information are allowable, and how to manage the governance of that information after it has been created.
Yeah, in some ways, there's like what we're being guided to by, the EU with GDPR. Just last week, the White House released another proposal. I don't know if they signed it, but it's looking at the beginnings of another safe harbor, so we can start working with European data centers again. But GDPR is a relatively well-written piece of legislation, and it gives us a lot of ideas on how to manage the data, right? The right to be forgotten, how we share data with third parties. But also what's interesting, I don't know if you've caught this, is that third-party data collection, so a Google Analytics or Adobe or some other, that data collection is quickly being ruled as, not compliant to a lot of countries' privacy. And first party data creation is actually in line with how, the EU and others would like to see businesses and applications evolve. And the reason for that is there's no intermediary that can kind of get in the middle and be like, oh, we decided to do something different. You click this EULA not realizing that's what you meant to do. And so the first thing is understanding like the policy landscape. And so I think GDPR is a good guidance for a lot of us on like how we store the data, how we ask for permission with the data, how we give people the right to be forgotten, and then also how we collect it. So trusting, others to collect the data on our behalf and do something with it. While it's easier because they give us a schema and you can just put it on, generally you've lost the sort of the element of like the lineage of that data. You don't know what's happened to it. So it's very hard for you to commit to it. And I think ultimately what individuals want from people that use their data is accountability. What did you use this data for? What did you collect on me? And did it ultimately make me as a consumer better off? So that leads into the second part of this is it's possible now to collect huge amounts of data of things that people didn't even realize were, an interesting data point. And what generally I would recommend is, understand what your business policies are. Do you want to collect gender? Do you want to understand ethnicity? Do you want to have zip code? How do you think about what data is important and informative and build a tracking plan to support that? And then the other thing is pseudo-anonymize by default. So we encourage our customers to always pseudo-anonymize, in some cases anonymize data as well. And that really helps customers, kind of build a policy. Like at that point, once you've pseudo-anonymized and you've collected the right data and you've got an understood business policy of what you're collecting and not collecting, and you've kind of got the GDPR stuff built in, which we'll help you go do as well, then you've already got like a platform that is largely conformant to what the guidance of, I would say the EU is probably leading this. It's one of their best, I think, innovations in a long time is what they've done with GDPR. And I can't believe I'm saying that, but I actually grown to love this piece of law. But then the other thing is what we do with it as data engineers. And I think as a data engineer, I think we all have pretty good moral compasses. We know that we should, make the right decision. But ultimately, the way I look at it is like you want to protect that customer's data. You want to be making a decision that makes their life better because of it. You could argue, does a better glasses buying experience make my life better? Maybe, maybe not. It's not going to change my life. But if I can get through and have options that I might not have had before and I feel more confident, then I think that's adding some value to that individual. And so I like to use like, is this adding value to the individual as a litmus test? And then the third thing I'll say is your ability to react to things that change. I don't think people wake up in the morning and be like, I'm going to do something sketchy, but things can change. So I'll give you a very real example. During COVID, I was working on an application that was basically approving credit cards, basically approving like different credit applications. And like, we shut the country down. Everyone was going home. We didn't know what was happening. Certain neighborhoods were much more affected without being able to go to work every day than others. So what happened was zip code became a really strong indicator of whether someone was going to be able to pay their credit card payment or not make their credit card payment almost overnight. Now, in a time when like everyone's like in a really tough position, the banks actually were like incented to try and help these people out, but their systems were effectively blocking based on zip code. So zip code became a very biased indicator of whether something should be accepted or declined. Now, none of us would have thought zip code was a bad thing to collect prior to COVID, but it turned out it was a really bad thing to weight your models on afterwards. So what do? Do you drop the column? Do you stop collecting it? Do you reweight it? The answer is you've got to be able to like understand like, okay, that column suddenly became, important. Do you hold that back? Do you create another view for it? And so that level of flexibility and understanding is what's really important, the ability to react. And when you have these complicated ETL pipelines, it turns out you don't know if zip code was used in that motion way upstream. And so you're able to sort of make these decisions inside your schema and drive that inference. And so that's a sort of a third part to that compliance angle. The fourth thing I would say, because this is a complicated and burly topic, is knowing where your data flows. And I do think this is where people are going to get more and more in trouble over the next 3 to 5 years. And as data engineers, we have to think about this. General rule of thumb, if you create the data in Europe, keep the data in Europe, pretty obvious. Maintain that from your pipelines is actually really hard to do. One of the companies I worked with in a previous life, we actually didn't know where in the world your files were stored because that was just the way the infrastructure worked. It just, who knew? It could be in Germany, could be in Australia. Your files existed somewhere in the ether, but we never knew. And so I think as data engineers that you have to be able to explain that your data is still in place. And if you can explain it, then generally the auditors or people that want to understand will generally be pretty happy with you and be supportive. And I'd say the very last thing is like Apple and others. I mean, with ITP, Apple basically stopped using cookies. So we're seeing a massive shift in how we're using cookies. I expect to see a lot more there. There's even some rumors about how like Apple's going to start looking at how they price things around those pieces. I think those are all really important things to do. Like that's the way they're going to approach Apple's such a large part of the market. I think that for us is part of what this type of data creation can also help for is be prepared for those changes. Because I do think customers do want more privacy. I do think we're going to see sovereign nations have different opinions for each other. Like already we're seeing countries in Europe shifting. So like Austria, Germany, France, Spain, Italy, Denmark all have banned GA effectively from a data collection tool. So that flexibility is sort of immensely important.
As far as the organizational aspects of managing behavioral data and data creation, what are some of the ways that you have seen the adoption of that strategy impact the team dynamics or the ways that teams are structured and organized?
I generally see the teams break into like two or three, usually three distinct functions. One function is sort of the running the business function. So they're like they're using the data to produce these very specific reports that everyone runs the business on. So that's kind of what we know today. We see the metrics tables that builds out. The second is this evolution of like behavioral understanding for the customer. Almost like if this, then that. There's almost this element of like, hey, we see this behavior equals that. And their ability to produce that and repeat that becomes far more powerful. Do these three steps and this event happens. So the ability to analyze the customer journeys, analyze the system journeys goes up. And so that's the second type of evolution of the team. We see these teams like defining journeys. And then the third, which is kind of my favorite, is when you see people activate those journeys and they start to actually take those insights in real time, change the behavior. It's a good, you know, I like that does this is Auto Trader. So what they do is they have this concept of how you consume the different like the different cars, and they'll actually figure out what cars you like and dynamically change the cars you're seeing as you scroll down. So this concept of scroll depth and scroll depth location, which is cool. And so that Auto Trader UK, I should say. And what's cool with that is one is they've taken the behavioral insight that as you scroll, you kind of want to see more of the car you like further up the stream, but also you want to go through and be able to say, all right, change the behavior of the application based on that. And so you're taking behavioral data for how I like Toyotas, but my stream's got Nissans in it. So therefore it's dynamically changing the behavior of Toyotas and changing the applications as I scroll through it. So that's like the first is just a view of the business, true understanding of the business. The second is definition of the behavioral, if this, then that. And then the third is the actual activation of that behavior in applications, which is super cool.
Yeah. It also brings in the complicated aspect of, kind of nature versus nurture to some degree. We're using behavioral data to inform this application behavior, which then influences the actual behaviors that the user is creating. So, did their behavior map to a certain pattern because of the way that we changed the application as a result of their information, or is it the other way around?
This is an ML debate. I've seen this with so many examples where like, do we bring people in and force them to have these we naturally force them to make decisions? Here's the way I think from a data perspective is there's like the intention, right? What's the intention of that, that user agent? Intention is they want to find a vehicle that suits them. The intuition is like, okay, is this a good car for me or not a good car for me? I think generally, I still believe humans have the ability to understand the intent and the intuition. They might have very degrees of capacity for intent and intuition, but generally there is that sort of cognitive ability to kind of go make that decision. And then I think the other thing is to make this individual better or worse off by doing this. If you're selling them sending something bad, but they choose it because it's the only option, that's them being worse off. So I don't agree with that. But if you send them a better option, they're better off for it, then I'm okay with that. And so it's about, and how do you score them? I think it's, that's where I think individuals still know that that's an option. So that I think the choice and optionality sort of provides a natural control for that. We could argue that social media doesn't give you the same natural controls, and so therefore it's more of a controlled environment. But generally in a lot of stuff we work in, you're in these sort of open ecosystems. So it's less of a, are we forced them to choose a Toyota because that's all we showed them? So yeah, my general rule of thumb is like, if you make their lives better and you give them the choice between, you give them both intention and intuition, then generally you're okay.
And so now digging a bit more into Snowplow itself, we didn't dig too much into the specifics of it because I did a pretty good interview with Alex Dean, one of the creators of the product, about 4 years ago now. And so I'm wondering if you can give some of the notable updates or changes to either the technical aspects of how Snowplow is built and maintained, as well as just some of the shifts in the product focus or the general kind of intent of where you're trying to take the product in the business.
A lot's changed and grown. This just highlights some of the things we do that we've talked about today. So first is obviously we focus on data creation. So we have all the ability to create the data, maintain pipelines, etc. But what I think is interesting that we see is the ability for us to enrich on those pipelines, but also dynamically adjust the schema. So how we do schema evolution with you, we allow you to like update and evolve the schema. So that's a really big problem to solve that we solve for you as part of the platform. And then the other thing we've really focused on a lot is just the different types of cloud data warehouses we support. And so, we see a lot more customers now just default Snowflake. We see a lot more Databricks. We've still got a lot of Redshift out there. BigQuery is still there. And so we've spent a lot of time like optimizing performance for those loaders as well, just because, in some of the cases, we're talking billions of events a day. And so I just think the way data is scaling now is super exciting, but also there's just a lot of technical complexity that we take care of customers to do that. There's also just the way that we deploy this now. So there's two main ways we see this deployed. One is what we call private SaaS, which is effectively we would deploy inside of a customer's VPC. So if you're a large multinational and you want to have complete control inside your own VPC, we effectively backplane and deploy it inside your environment, which maintains the sort of data integrity for behavioral data. And the other is we have a cloud version, which effectively allows you to like spin it up. We'll manage the front end infrastructure. The data stays on your side and effectively goes to your data warehouse, but we take care of the sort of the provisioning of the platform per se. It really depends. I think the private VPC option, it's much more enterprise. Is all the enterprise controls you'd expect. We sort of see a lot more of our larger organizations doing it. The cloud version, we see all sorts of departments, smaller organizations, some large organizations trialing it. There's sort of a bunch of options there. And I think, to a lot of your questions around this data, it's considered to be sort of the most powerful asset companies have. So people have, want to treat it accordingly, or they know they need to do it, so they create it that way. We've also been evolving around what we call like the tracking catalog. So I'm glad you brought that up. We saw these spreadsheets, like we've got to do better. And so we built a tracking catalog, which really helps customers. It includes all the metadata and version tracking. We have obviously the schema management I talked about. So like a lot of that, like what I'd call data product management, like all the different things you need to do to create data products is really what we're focusing on building out. Like, if a year from now you're like, if we need to build a data product, the answer is Snowplow, then I've pulled off my mission. Because there's all this complicated stuff that data engineers need to solve for. And sort of, at least my vision, the team's vision is we want to get those tools to make that data product management lifecycle really powerful inside Snowplow. So that kind of gives you an idea of where we're heading. I think the last thing that I find really interesting is that we're often asked, like, what's the best practice for e-com? What's the best practice for like customer data? We're figuring out how we can provide more of that insight because we did a survey a little while ago and a lot of the people come back like, look, this is a really hard job. Like people have ridiculous expectations of us. We've got lots of cold start problems that shouldn't be cold start problems. So is there a way to sort of share more of that? So one of my other sort of pet projects has been able to like make that more available for other data engineers. So at least you see how stuff was built. We give you like a starting place, like an accelerator to kind of work with that. And so that's something else we're working on. It's like, if I can help someone build a composable CDV way faster without having to like reimagine the world and go talk to 50 consultants, if I can make that available for more people, I think that's a good thing. And I hope they choose Snowplow to build on top of. But we're going to be, continuing with that open source thesis, and sharing a bunch of that insight is also pretty important to me too.
Another interesting aspect of the problem space that you're working in and some of the ways that it plays off of the overall trends in the data ecosystem is the idea of the so-called modern data stack that seems to have catapulted a lot more businesses into the space of feeling comfortable and capable of being able to actually build out a data platform and start to bring in some of these analytical capabilities and analytical workflows. And I'm curious if you have seen any meaningful impact on the adoption and uptake of Snowplow and some of the maybe kind of degrees of sophistication that teams are able to move into as a result of the broader availability of these managed data tools and data platforms, so that they can actually start to think about how to incorporate data creation and behavioral data into their overall kind of data strategy.
Look, I love what the modern data stack has done for a lot of organizations, right? Like previously, you'd have to get some of these capabilities, you'd have to like spend millions of dollars and spend so much time doing it. And so it really de-risked the opportunity to kind of get these outcomes and have exposure to these technologies. At the same time, it added like so many choices, right? And so I think often there's this problem of like, what is the choice and how do I start and where do we go to from that? And so where I think what's been awesome is that we now know most kind of our customers we work with have some cloud data warehouse that allows us to have super performant, highly scalable. There's no IOPS conversations anymore. Like it's, put on the Snowflake and it just scales Databricks, what have you. That gave just a lot more accessibility. I think the other thing is that the businesses sort of know that this data engineering, data science thing exists, and they expect it to solve world hunger for them. So they ask so many questions of the business. And I think up until this year, right, businesses were just putting more money into data engineering and data analytics, maybe not in the people, but just more tools, more stuff, more requests. And so that created two things. One is I think that data engineers have a seat at the table now that they didn't have before into the business. And secondarily, like I think the business has also asked the data teams to provide insights as well as just the raw data, to provide something that's consumable by the business. And I think that shift is something I'm seeing, especially this year, especially since we've sort of seen budgets get a little smaller this year and people being a little more conservative, like how they're making purchase decisions. Like, hey, we understand the stack exists, but like, how do we transfer the value between the great data work the teams are doing and what the business is asking for? And so that's definitely been something like, if I just talk about the conversations I've had this last year, it's more like, we understand this, the modern data stack can build this great stuff, but how do we get this to a business outcome faster? How do we define value from this? And I think for us, the way we would sort of talk about it with our customers and even with each other is, by producing data products that the business can consume, the business sees real value in that product. That's the value exchange you create. And so I think the modern data stack has given us all these tools to create these data products far faster and way smarter ways with so much data and be way more accurate, and. But at the same time, there's so many tools, like we kind of want to give guidance as well on top of the modern data stack. And so that's been key for us and sort of how the modern data stack has opened up opportunities that weren't there before. Secondarily, I think the other thing is you've got to be able to work with that ecosystem. And so for us, we've got an open source option there for folks. We work with, as many folks as we can. We sort of have, an open architecture in the way we think about how the data is created in our open source approach. And so that I think also helps, put it into the hands of more people and more engineers. For that, I'm super grateful. 15 years ago, there wasn't a huge community of data engineers. It was a much smaller, DBA community. And I'm pretty grateful for like what the modern data stack has also created and like capability in their ecosystem as well.
Data engineers don't enjoy writing, maintaining, and modifying ETL pipelines all day, every day, especially once they realized that 90% of all major data sources like Google Analytics, Salesforce, AdWords, Facebook, and spreadsheets are already available as plug-and-play connectors with reliable, intuitive SaaS solutions. Hevo Data is a highly reliable and intuitive data pipeline platform used by data engineers from over 40 countries to set up and run low-latency ELT pipelines with zero maintenance. Boasting more than 150 out-of-the-box connectors that can be set up in minutes, Hevo also allows you to monitor and control your pipelines. You get real-time data flow visibility with fail-safe mechanisms and alerts if anything breaks. Preload transformations and auto-schema mapping precisely control how data lands in your destination. Models and workflows to transform data for analytics, and reverse ETL capability to move the transformed data back to your business software to inspire timely action. All of this, plus its transparent pricing and 24/7 live support, makes it consistently voted by users as the leader in the data pipeline category on review platforms like G2. Go to dataengineeringpodcast.com/HevoData today and sign up for a free 14-day trial that also comes with 24/7 support. And in your work of moving into your role in Snowplow and working with customers and helping to understand some of the strategic and tactical elements of data creation and behavioral data management, what are some of the most interesting or innovative or unexpected ways that you have seen these practices or Snowplow specifically employed?
I'll give you another one, which I haven't seen. I've seen it like in some of the experimental elements, which is using Snowplow to create behavioral data between warehouse robots. And effectively, it takes each of the different warehouse robots, creates an event stream for each individually, and then tries to bring them back together into one, swarm of robots themselves. And so I think that's, not just look at the behavior of like interactions over a point of time, but also how interconnected systems can work. That I think was a pretty interesting use case, which I think most of us kind of geek on, like the swarm mentality. The other one I think is kind of interesting and probably something that we all experience every day. If you ever go like a paywall, you go to like an article, like it sort of pops up on your feed, you click it, and then you get like to the first paragraph, it says like, please pay here. For the longest time, that paywall optimization was kind of just defined by editors. It's like, the sports articles apparently were the ones to like not convert on. So you gave away lots of sports articles, but then the like gossipy ones were better for conversion because it was like, it's going to be a point in time. So this whole like kind of not particularly scientific, but kind of rote way of like how to figure out what to optimize the paywall on. But what we saw happen was companies like the Globe and Mail started to build their own system for dynamically adjusting the paywall. And they actually went and disrupted the paywall industry by taking that behavioral data. And they created a company called Sophie. I think it's spelled SOPHI. And it basically is a platform now that dynamically optimizes paywalls. And what's cool with that, it turns out that the gossipy articles weren't the highest performing ones for converting. So you can thank the data for getting more Kim Kardashian articles. And so like just that level of like behavioral information that can inform lots of other things became a really powerful product. Those are two examples, I think, where you see not just the individual behavior of like one entity, but then how do you take multiple entities and provide that to be some, profitable or usable service as well.
In your own experience of working in this space and working with customers, and as well as trying to use Snowplow and behavioral data for solving your own problems, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think my advice is, really do think through like how you think of your tracking plan up front. And so that sounds so simple, but if you do that right, everything else flows from there and you can evolve it. So what I see go wrong is when someone starts with like all these different things at once and tries to converge and conform. I think where I see it is like start simple. Start with a single tracking plan for your website and define your customer. And then once you've defined it there, evolve your schema to support a mobile application. And in some ways, where I see it go wrong is when you try to build these like massive master data management projects and you try to solve data for the whole company. I don't think I've ever seen one of those be successful. I'm sure there have been, but I can't think of too many that have like been like, all right, we nailed it. Our data problem's now solved. And what I think Snowplow allows you to do is focus on choosing one problem statement and then you can evolve it to the next one without having to like massively refactor all of that scheming. So I think that would be the thing that I've seen allows data engineers and data teams to evolve with their deployment. Generally, when you see these huge projects, I try to break them down into smaller chunks. So that's kind of the challenges I've seen. And I think the other thing is there's a bit of a cultural shift, I think, with Snowplow. So if you've been doing ETL models forever, the concept of creating data sort of seems a bit foreign. Like what, can we create enough? And like, what's the difference between data creation and data exhaust? And like, is it really that broken? And so there's this almost like, there's a sort of moment I see working with customers like, well, ETL works. And you sort of show them data creation. They're like, this actually works. We've just had this muscle memory to ETL things for so long. I think it definitely is a different way of thinking about it.
And so for people who are trying to make their lives easier or be able to build more effective analytical and machine learning systems, what are the cases where Snowplow specifically or behavioral data in general might be the wrong choice?
Yeah, in those scenarios, like I like to ask a customer if they're data first or data centric and like where they sit on that that modality. And I think if an organization just wants to magically have this behavioral element and doesn't consider themselves to be data first or data centric, I think generally I'm like, okay, we're going to coach them towards thinking that way. Or we're like, okay, if you don't believe that you can solve this with data, you just want the end outcome, I feel like that's usually an indication they haven't reached the data maturity that we might be looking for. That's one. For me, the other thing I look at is like, okay, how do you think of like how you present the data? So we're not going to build all the fancy dashboards for you. We're going to plug into your existing systems. We don't come with a bunch of like, graphs up front. Again, if you're data first or data centric and you've got visualization teams, you've got enterprise systems, that's kind of where we sit. So we do require some level of data sophistication. So you can't just deploy and, pointy clicky come out with like a pretty picture at the end. You're gonna have to do some code and do some data engineering.
As you continue to work with your customers and work with the business, what are some of the things you have planned for the near to medium term for Snowplow or any particular projects that you're excited to dig into?
Data product management is a big area of focus for us. Like, what does that life cycle look for data products and the evolution, how you create them? We're also thinking about how we talk about data product accelerators. So I talked a little bit about how we think about how we actually provide the path to building a data product. So you remember I talked about, the pain people feel in like building data products and how hard it is to repeat them. So I spent a long time thinking about this. And what I realized is like, you can't just give someone a recipe for a data product because everyone has like different equipment, different elements. So what we do at Data Product Accelerator is we really think about the end outcome of the data product. And then we kind of take people through a cooking show. Like, hey, here's what you set up. This is what you set the stage. Here's how you deploy your schema. At this stage, think about, connecting these pieces up. Here's how we get to that end outcome. And so we are on the path to produce a number of data product accelerators. We start off like web and analytics ones. We also look at things like e-com. We have things around GDPR. And so we're just taking a lot of that knowledge we've built up and building it into these accelerators to help customers and data engineers build their data products. And, I think as a data engineer, probably not a full-time DE anymore, but I definitely still have that in my blood, that if I can help people start out with the idea of what they want and give them a walkthrough to get, 80% of the way there, I think that's like a good service for data engineers, but also for the business. Like the business, like is pretty ruthless now asking you for time to value. How fast can you build these things? So when someone asks you for these outcomes, I'm really hoping that from Snowplow perspective, we can build these accelerators. So you can like, all right, someone needs a composable CDP. We'll deploy Snowplow. We'll run through these steps. We're up and going, hey, customer or internal customer, here's what you need. So you can kind of build what the customer wants way faster. And you apply, schema revolution, everything else in it. I think it's a big amount of value we can help data engineers have for their organizations. Those are two things that I'm working on at the moment. And then the last is just more ways of deploying. So we talked about like the loaders. I know it's sort of in the bowels, but getting really efficient about how we load Databricks and Snowflake and others has a huge effect, especially when we're getting up into the millions or billions of events a day. So yeah, those are three things that are coming. Definitely check out the data product accelerators. Data product management is something with a tracking catalog. It'll officially be out, when this podcast comes out. And so that's another thing we've got going. And, for me, like I'm just trying to get as much new stuff out as possible. Like it's fun, but also I know I can help people that are my friends and people that, face a lot of the problems that we face.
Are there any other aspects of the work that you're doing at Snowplow or the ways that data creation and behavioral data can be used in analytical and machine learning contexts that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, we didn't talk a lot about like feature engineering and just the advantages of how data creation can solve that. So a lot of my background most recently has been in ML. And so the beauty with doing data creation is you really introduce no noise into it because you created the data. So as long as you're constantly evolving, creating more, like collecting more, or adding more features, it's really powerful when you do, feature creation or you create your feature store. And so that's the beauty of this whole approach is in some ways, the problem we really solve is we remove all the noise from your data and we get it ready. And so you'll hear us talk about AI ready data. Generally what you're doing when you're sort of pre-processing data is you're removing the noise. You're trying to like provide an informative feature set. And so when you take Snowplow's approach to this, you effectively have the atomic rows, which effectively become informative features, but also you're able to use a lot less data to train the model. Because there's less noise, because you have to do like less transformation, then those rows are much more informative. So that then totally changes your loop speed for refreshing models. So you're able to train models faster, you're able to detect drift faster, you're able to retrain and have a model factory run faster. So the advantages downstream from having a highly performant data creation and data management approach dramatically solves for how you look at how you drive ML, dramatically reduces the costs. And so it's kind of a little bit of a sort of inverse, I think. We went through this big data phase and big data was super helpful. But now if you're looking to drive applied AI or ML use cases, you really want what I'd call minimum effective data. So you want the smallest amount of informative effective data to train that model. And you hear there's a number of different concepts just around tiny data, tiny ML. There's a bunch of that stuff popping up. But really what I think is a little secret is if you can create the data to be highly specific, you can have a lot less of it to train. And that is, I think the downstream implications of applying data creation just for ML justify switching away from an ETL as a way of sourcing the data. And, if anyone's ever gone through the process of training data and cleaning data before you do your model, I would say 80-90% of the work is not the math or the Python to get it running. It's, what is the data you're working with, and does that data adequately reflect the behavior of who you're trying to work with? Some of my most interesting ML discoveries have nothing to do with the data, but it's more about what the people are doing around the data, what we could extrapolate from that data based on, someone's repeated behavior or something we're trying to influence. And so that was probably the thing we didn't touch on, which is, probably a whole other podcast itself, which I think is a really interesting branch of what data creation can do for ML.
Yeah, well, fortunately, I actually have a whole nother podcast on machine learning, so we'll have to set up another conversation around that. Definitely interested in discussing kind of the ways that the behavioral data and data creation aspect can feed into the feature engineering and how that might hook into things like feature platforms or feature stores and the overall machine learning lifecycle. So, as you said, a whole nother podcast episode just on that. But for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Look, I think we've got a lot of tools and technology, but what I think is really missing is how to bring those together. And so I do think there's a real opportunity for us to share more and provide more about how we bring those pieces together. And so that, for me, the concept of a data product accelerator, I think is an example of the technology, the tooling is there, but if we can bring that repeatability to technology and tooling, I think that's going to help people so much. I don't know if you've ever experienced this when you're stuck trying to do something, you finally find someone's code that actually works. Oh, I totally missed that. I think right now we've got so much innovation, these individual tools, that only a small group of people have actually putting them together in a way, and it's really hard to access that. So I think for me, if I can bring some of that insight into the product and can help people have access to that as part of the platform, I think that's going to be really powerful. And if I can just save, someone an hour or help them get to the point where they can build something an hour faster that, makes them more powerful and, builds from that community, I think that's a net good thing. And I think that is something I want to weave in technology and tooling far more than any other gap I see. There's plenty of other nerdy gaps, but I think if you ask what's the biggest impact, it's helping my data engineering friends figure out how to get to an outcome fast without having to go through 100 docs, search, drink 50 coffees to try to figure it out. Probably not the most geeky answer you ever had, but I think if you ask me what's a really big gap we could solve for, that's probably number one.
Oh, that's a great answer. You'll just have to go drink the 50 coffees for fun.
Yeah, that's right. That's right.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at Snowplow and your perspectives on the applications and utility of data creation and behavioral data for being able to build data products and analytical systems. So I appreciate all of the time and energy that you are putting into making that a more tractable problem for your customers and the ecosystem, and for taking the time today to share it. And I hope you enjoy the rest of your day.
Yeah, thanks, Tobias. I really enjoyed it. Thanks for the thoughtful questions and the conversation, and good luck to everyone listening in, and hopefully we get to keep chatting.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.